Welcome to the lecture on testing of random numbers. So, in the last lecture we discussed about the random number generators and we discussed about the congruential generators and we had seen that how the random numbers of uniform distribution can be generated. But then it is also very important to see that these numbers should be tested for their uniformity and independence, because these are the two main criteria which a random number or the random numbers which are generated they must fulfill. So, the first test is the uniformity test. So, basically there are two methods of testing the uniformity, and one is Kolmogorov-Smirnov test and another is Chisquare test. So, both are the frequency test, and as it is clear that these tests measure the degree of agreement between distribution of sample of generated random numbers, I mean whatever we have generated. So, sample of generated random numbers and theoretical uniform distribution. So, basically you have to see that whatever random number you have generated, how much they have the similarity with the theoretically uniform distribution. So, based on the null hypothesis of no significant difference between the sample distribution and the theoretical distribution, we come to the conclusion. In between we have to find certain parameters, we have to refer to some tables, and from there we try to come to the conclusion that okay, based on this hypothesis we can say that it cannot be rejected that they are not the uniform distribution. So, this is how these two tests are tested on the random numbers generated. Now, coming to the Kolmogorov-Smirnov test. So, what is the process of this Kolmogorov-Smirnov test? So, when you are given a sample of numbers, suppose some 5 numbers or so or 10 numbers or so, then based on that you are basically first of all arranging them in orders, and then you are basically finding certain parameters d plus and d minus that we will see, and then these are calculated based on these numbers and then they are compared against the tabular data which is basically for the ideal uniform distribution. So, for that particular value they are compared, and then if satisfy the condition which is stated for the uniformity, then we say that yes, on the basis of that the hypothesis cannot be, or the numbers can be said to be uniformly distributed, or they are said to pass this uniformity test. So, let us go to the principles of this Kolmogorov-Smirnov test. So, what happens, as we know that in the case of uniform distribution you have certain CDF that you know. So, in that fx will be x. So, for certain from up to 1. So, like for the uniform distribution what we see is we have x when x is 0 to 1. So, this is for definition of this uniform distribution, that is CDF. Now, what happens, you have the sample from random number generators that is R1, R2 to Rn. So, and then you have the empirical SNX. So, empirical SNX will be defined by SNX will be number of R1, R2 to Rn which are less than or equal to x and divided by n. So, what happens as n becomes larger, you have the better approximation to the uniformity. So, if the sample size is larger, if you have large number of random numbers, then the chances of getting the uniformity is higher. Now, the Kolmogorov-Smirnov test is based on largest absolute deviation between Fx, that is your uniform CDF distribution CDF, and Snx, that which is given to you for checking that uniformity over that over range of random variables. So, for that we are finding certain parameters, and these parameters are, one is d equal to maximum of Fx minus Snx. So, this d is basically calculated. Now, the steps are like this. The steps are step 1. So, you are given the data. Now, what you do is you are ranking the data, rank data from smallest to largest. So, first of all, whichever data you are given, you have to rank it from smallest to largest. Next, you have to compute the parameters. So, so you will compute d plus, which is defined as maximum when I is more than equal to 1 and then less than equal to n. So, it will be I upon n minus r I, and then you have d minus, that will be maximum of again I between 1 to n, and it will be r I minus I minus 1 by n. So, these two parameters you are going to find. I means I will vary from 1 to n. So, you will be given certain number of values, like you are given 10 values. In that case, the capital N is 10. Now, I will start from 1 to 10. So, for every number you are calculating d plus as well as d minus. Then next you are computing d equal to maximum of d plus and d minus. So, once you compute d plus and d minus, you are going to have the value of d. So, maximum of these two. Then locate in table critical value of d alpha. For specified level alpha in sample n. We have already discussed in the last class that for such test one alpha is given, one level is given which gives the probability, I mean of rejection, it must be, or probability of telling that yes, it is passing the uniformity test. So, in that case alpha is given normally, and normally it is taken from 0.01 to 0.05 as we had discussed. So, that value will be given to you, and for this you have the table. So, Ks table is given. From that table you have to locate the value of d alpha, and then if sample statistics d is more than d alpha, null hypothesis are rejected. So, if the d is found to be more than d alpha, the null hypothesis tells that the sample which has been tested, it is not having the uniform distribution, and if d is less than d alpha, in that case we say that no difference has been detected between true distribution and uniform distribution. So, what it tells that you are getting this d which is nothing but the maximum of this d plus and d minus, and that has to be less than this d alpha, that is from the table, that uniform distribution table, you will get this d alpha. Now, this d alpha, for a specified alpha you will have the table like this. So, in this table, if you have n number of data, you have the degree of freedom, that is n minus 1. So, you will see against this degree of freedom value, if suppose you have 10 data, your degree of freedom is 9, and then I mean according to this table, in front of 9 you have to see what is the alpha value, what is the value of alpha which has been set. So, for that alpha you are going to see the value. So, suppose d alpha is 0.05, so for 10 it will be against 9.432, or for 5 samples it will be against 4.624, like that, and this d alpha should be more than this d. So, in that case the sample statistics d, and this if d is less than this d alpha, in that case we say that there is no concrete evidence that it is not uniformly distributed. So, it is basically said to be uniformly distributed. Now, we can check by checking the 5 random digits, and then we can say, we can see how this test is being carried out for any number of digits. So, if there are suppose 5 digits, there are 5 digits given 0.44 and then 0.81, 0.14, 0.05 and 0.93. Suppose you have these 5 random numbers given, and you are told to see and ensure that whether they are uniformly distributed. In that case, what we see here is we have, and also you are given alpha value as 0.05. So, you can very well check it here, you see n is 5, you have 5 data, so n is 5. Now, if you see you have the value r I, then you will have value I upon n, you have I upon n minus r I and r I minus I minus 1 upon n. That is what these parameters are required you to be calculated. Now, for every I, so you have one value is r I first number is point. So, first of all you are going to take them in a order, in the increasing order. So, increasing order, the first number will come as 0.05, second number will come 0.14, third number will come as 0.44, fourth number will come as 0.81 and fifth number will come as 0.93. Then I upon n, I is 1, 2, 3, 4, 5. So, I is 1, I is 2, I is 3, I is 4 and I is 5. So, I upon n is 5 anyway. So, it will be 0.2, 0.4, 0.6, 0.8 and 1. Then I by n upon minus Ri. So, I by n minus Ri will be this minus this. So, that will be 0.15, this will be 0.4 minus 0.14, 0.26, this will be 0.1416, this will be minus 0.01. So, minus value needs not be taken, and again this will also be minus. No, this will not be minus, this will be 0.07. Then Ri minus I minus 1 upon n. So, Ri minus I minus 1 upon n, so that will be 0, so this will be 0.05. Now, I will be 2, so Ri minus, so 0.4 minus I minus 1 upon n, so that will be 0.05. So, that will be 0.14 minus I minus 1, 2 minus 1, 1 by this is 5, so that is 0.2. So, it will be 0.14 minus 0.2, so it is a negative number. So, we are not going to write it. Similarly, 0.44 minus this will be 0.4, so it will be 0.04. 0.81 minus 0.6, it will be 0.21 and this will be 0.93 minus 0.8, so it will be 0.13. Now, what we see is this is D plus. So, D plus will be maximum of I by n minus Ri. So, maximum of this will be 0.26 and D minus will be maximum of Ri minus I minus 1 by n. So, maximum is 0.21. So, sample statistics say that D will be equal to maximum of these two values, that is 0.26. Now, we have to compare it, or we have to see that how it is faring, whether it is more or less as compared to D alpha. So, D alpha we have to calculate. Now, for D alpha calculation we must know the degree of, so from this table we will try to see what is the degree of freedom. So, as the number of values are 5, so degree of freedom is 4, degree of freedom is n minus 1. So, against 4 we will see the D 0.05 value. So, that value is given as, so D alpha, that is 0 point, sorry. So, this D alpha it is given as, so in the D alpha basically degree of higher. So, this value is given 0.624. So, we have to compare against D alpha. Now, in this case D alpha will be computed for n equal to 5 and the alpha is 0.05. So, in this case we are in the case of Kolmogorov-Smirnov test, we are looking directly against 5 and then for the D alpha of 0.05. When we talk about the different test, in the case of chi-square test, there we need to have this degree of freedom value and there we see the degree of freedom as n minus 1. So, in this case what we see is we have the D alpha value will be taken as against 5, you see D alpha is 0.05. So, that is 0.565. Now, what we see is this is 0.565 and this is D is 0.26. So, this 0.26 is less than 0.565, that is D alpha. That is why we can say that this null hypothesis tells that you cannot reject this hypothesis that these numbers are from the uniform distribution, or they are not having uniformity. So, it means they are passing this hypothesis test of uniformity. So, this is how this Kolmogorov test, Smirnov test is carried out. You may have many number of samples, and as you see, you have, as we go more and more, you can you see that you this get for any number you can have these values. Next type of test is the chi-square test. So, in the chi-square test again you find certain parameter, and based on that you are checking the uniformity of the sample. So, in the chi-square test what is done is you have a parameter chi-square. So, this chi-square is defined as, so this chi-square test so this square, this is defined as summation of I equal to 1 to n and then OI minus EI square upon EI. So, you have these values, this chi-square value is basically calculated, and again this chi-square value is compared against this standard table. So, in this table you have this nu, that is degree of freedom. So, from here in this case the degree of freedom becomes the number of I minus 1. So, in that case you have, against that you have to just see the chi-square value, and again same condition is applied to find the values. So, what is done is OI is observed number in the class, EI is expected number in the class, expected number in the ith class, so from uniform distribution expected number in each class should be capital N upon small n, that is EI. Now, you have for equally spaced classes n is total number of observations. So, what you do is, in this case you have the, if suppose there are many numbers which are given and you have to test its uniformity. So, you are finding the intervals and you are finding the frequencies, and you know that you have, in the case of uniform distribution, what should be the frequency. Suppose you have a number and you have put these numbers in 10 intervals. So, in that case the interval, every interval must have ideal frequency of 10%, I mean 10 itself, if suppose there are 100 samples. So, every interval should have the frequency of 10 in the case of uniform distribution. Now, when we have any sample, in that sample if you are putting in the interval, that may not necessarily be 10, it may be 8 or it may be 12, it may be 9 or 11 or it may be 10 even in some cases. Now, in those cases all these OI and EI we are basically going to see. So, once you have that, you are going to find OI minus EI square, and then that will be divided by EI. So, you will get chi-square, and sampling distribution of chi-square is approximately the chi-square distribution with n minus 1 degree of freedom. So, it is assumed that it is with n minus 1 degree of freedom. Now, from there once you get this chi-square value, this chi-square value will be again compared with this value from this chi-square distribution with new degree of freedom. Now, against the number of intervals, now you are going to have the degree of freedom, that is n minus 1, and against that for a particular alpha value you are going to find the chi-square value. Now, if that chi-square, if chi-square value for a particular alpha, so that will be, if this is more than chi-square of sample, hypothesis is not rejected. So, you will have the chi-square value from this table. This value should be more than what we calculate from here. If it is so, in that case we say that the null hypothesis is not rejected. We say that the samples form the uniform distribution. If it is not so, in that case it is will be said to be, it will be said that it may not be of uniform distribution. So, this way we can solve the examples in the coming classes, and then we will see that how they are solved and how we come to find these values. Next is the autocorrelation test. So, these two tests which we have seen, they are basically related to the checking of uniformity. Now, we will see that how we can come to the conclusion that they are not correlated. So, it should be seen that they are not correlated. It may be so happening when we get this data, we can observe that there is certain type of correlation between the numbers. If we find that, then in that case it is more predictable. So, then that is not a completely independent type of random number. So, basically this test is done to see that the numbers we generate, they are independent. Now, in that case you have the autocorrelation test. That test tells how to check that there is no correlation. So, for that a parameter is set, and this parameter again is calculated, and then based on that we are going to decide. So, as we see this autocorrelation test, these tests basically are concerned with dependence between numbers in sequence. So, whatever number we have, it will tell us that whether there is any dependence between the number. By looking at the number itself, many a times we have the notion that it looks to have certain correlation. Maybe that every fifth number, every third number, or after third number, after the first third number, and then after that, after every gap of 5 numbers, we see that there is a type of pattern in the numbers. In fact, if that is known, that is not going to be the example of very much an independent sample. So, that type of test is carried out using this autocorrelation test. So, computation of autocorrelation between every m numbers m is known as lag, starting with ith number. So, you will have certain number of random numbers, certain number of numbers which are random and whose correlation test is to be carried out, and in that you are said that among these numbers whether you check whether there is any correlation or so. So, it will start with the ith number, maybe 1, 2, 3 or so, and from there we are seeing that between every m numbers. So, it means I plus m, I plus 2m, I plus 3m, like that. So, you have different numbers, among them if you see that there is any, you try to find whether there is any correlation, you try to see that. Now, in that, so what you do is autocorrelation, that is rho im. Rho im tells the autocorrelation between the number which is starting at ith number and with m as lag. So, that is im. So, I plus m, I plus m, I plus 2m or so. So, between numbers Ri plus m, Ri plus 2m and so. So, it will be Ri plus m plus 1 into m. Now, it has to go up to m plus 1 into m is to be found. So, now for this, now this has to go maximum up to n, because we are going to have maximum of capital N number of numbers. So, it has to go up to that. So, in that case what you get is m is largest integer such that I plus m plus 1 m is less than equal to capital N. So, you have n number of samples which are to be basically tested. So, now a non-zero autocorrelation implies lack of dependence so following detailed test is appropriate. Now, we have the condition on which you have to say whether there is correlation or not. So, for that again you have H hypothesis. So, where rho im is 0. So, you are telling that there is no correlation, otherwise you are telling that since it is not equal to 0, it means they are correlated. Then, so what you do is, in this case now you have Ri plus m, Ri plus 2m or so. So, in that case you further find certain statistics. So, among them you are finding the statistics Z naught, that is the test statistics, that will be rho im estimator value divided by sigma of rho im. Now, whatever rho im you are getting, so you are getting this sigma im, and then based on that you are computing it through the uniform distribution table Z naught. So, this will be the table which is given. You have this Z naught given for particular alpha, you will be given this Z naught, and once you know that, you have to compare from there. So, further you will have certain conditions and certain parameters to be found. So, what you see is rho im you will be computing by 1 by m plus 1 summation of k equal to 0 to m r I plus km and r I plus k plus 1m. So, and minus 0.25, and sigma rho Im, that will be again decided by 13 m plus 7 divided by 12 m plus 12 into m plus 1. So, that this value you get, you have to compare against the standard normal distribution table. We have with mean 0 and variance 1, and then you are going to compare it, and if you are getting this value to be lesser, then you say that they are not correlated. You can accept this hypothesis, and otherwise you are going to reject it. So, we can have some problems we can solve in the lectures of these tutorial classes, which will be maybe after one class or more, and then we can see that how the problems of correlation can be solved and checked. Thank you very much.